let me know if you ever want to go back and look at these again. So here we are at chapter 16, digestive system, and digestion and the digestive system. What does that even mean? Digestion refers to the breakdown of large organic molecules into smaller molecules that can be absorbed. And then the digestive system performs the task of digestion, where food is taken into your digestive system or digestive tract, and then it's enzymatically broken down into smaller and smaller particles so that it can be absorbed through our bloodstream and then taken to either the liver for processing or other parts of the body cells that need it. So here are functions of your digestive system: the ingestion of solids and liquids through the oral cavity, down through the esophagus into your stomach, and then the digestion of organic molecules, the absorption of nutrients into your bloodstream, and then the elimination of waste. So getting rid of anything that your body can't use, that is considered waste. Here are the main organs of the digestive system. The pharynx refers to the throat, the oral cavity is the mouth. You have different salivary glands that will secrete saliva, which start the process of breaking down the food you eat. And then the food travels down the esophagus into the stomach, through the small intestine, into the large intestine, and then out through the rectum and anus. So that's considered our GI tract or GI tube. It's one long continuous tube. And then we have accessory digestive organs like the liver, the gallbladder, the pancreas, and the salivary glands that all add enzymes, digestive juices to help break things down. But in general, your digestive system is one long continuous tube or tract. And we call that digestive tract the GI or gastrointestinal tract. It's one long tube from the mouth to the anus, and then you have all the associated and accessory organs, again, salivary glands, liver, gallbladder, pancreas, that attribute or help with digestion. So here's the order of the digestive or GI tract: the oral cavity, the pharynx, esophagus, stomach, small and large intestines, rectum, and anus. So one long continuous tube. And then we have the associated or accessory organs. They're not directly in the tube or the digestive tract, but they do have ducts that lead into the tract. And these will be very important for helping break down the food that you do eat. The salivary glands produce saliva, the liver produces bile, the gallbladder stores bile. Bile is used for breaking down fats. And then the pancreas probably secretes the majority of your digestive juices and enzymes, and the pancreas will secrete all of its digestive fluid into your small intestine, where the majority of digestion occurs. So throughout this kind of one long continuous tube of the digestive tract, the layers of the tract are termed tunics. So think these layers of the digestive tract wall. So the layers of the esophagus, the layers of the stomach, your intestines, are all made up of these three tunics or layers. And they vary a little bit with how large they are or thick they are. But in general, throughout your GI tract, there's always these three tunics present. The mucosa is the innermost layer that secretes mucus into the tube. The submucosa is above the mucosa that contains all your blood vessels, nerves, and small glands. The muscularis will be your muscular layer, which will help to kind of squeeze or push things along your GI tract. And then the serosa or adventitia layer is the outermost layer. This layer has what we call the peritoneum is present, and it's called serosa. And if no peritoneum is present, then it's called adventitia. So those are the layers of your digestive tract wall. And you can see these layers as shown here. So the innermost layer is the mucosa layer, the mucous membrane that's secreting the mucus. You'll have lymphatic nodules there, intestinal glands. Then you'll have the submucosa layer. Right below that layer, you'll have glands in the submucosa layer. Then you'll have the muscularis layer. And again, the muscularis layer is the big layer of muscles. that will kind of squeeze and push the foodstuffs along the digestive tract. You'll have then the serosa layer, the serous membrane, the visceral peritoneum, connective tissue, and then simple squamous epithelium. And then within the serosa or adventitia layer, you'll have blood vessels, lymphatic vessels, nerves traveling through it. The mesentery is what will help kind of anchor these blood vessels and nerves within the serosa layer, so that all of your intestines aren't just kind of hanging out and going all over the place. The mesentery kind of keeps everything compacted and together where it should be. The enteric plexus refers to a specialized plexus or group of nerves that goes or the supplies nervous supply to the digestive system, the enteric plexus. The peritoneum then, this is the layer of smooth epithelial tissue. Mesenteries are connective tissues of organs and the abdominal cavity that kind of anchor and keep everything where it's supposed to be. The lesser omentum will be the mesentery connecting the lesser curvature of the stomach to your liver and diaphragm. And the greater omentum is the mesentery connecting the greater curvature of the stomach to the transverse colon and the posterior body wall. So these mesenteries kind of keep everything in place where it should be in your abdominal cavity, as well as providing kind of a connective tissue pathway for all of your blood vessels and nerves to travel through. So here we see the peritoneum and these different mesenteries as taken from a sagittal view, so a sagittal cut through the abdominal cavity, and you see kind of where these mesenteries are located. You have the visceral peritoneum, covers the organs. The parietal peritoneum covers the abdominal cavity. These are just connective tissue coverings. The lesser omentum is shown here. It connects your liver to the stomach. Then you see greater omentum connecting the stomach to the transverse colon and the posterior wall. You see the mesentery proper kind of holding all your intestines in place. So this is just, again, showing you extra connective tissue and how it's keeping all of your abdominal organs in place and connected. So then we'll start with your digestive tract. We'll start with the oral cavity. It's the first part of your digestive system. It contains stratified squamous epithelium, and it's under a lot of stress because there's a lot of foodstuffs going into your mouth at all times. So the stratified squamous will constantly be rebuilding itself, adding more and more cell layers to it as it's constantly being kind of very abrasive by the different foods and drink you eat. You have salivary glands within the oral cavity or in the exterior of the oral cavity, which are producing saliva, which will contain an enzyme to break down carbohydrates into glucose. The saliva also keeps your mouth clean, and it helps to dissolve and moisten food to just help the food get ready to get kind of into a nice slick or slippery bolus, so it can easily slide down the esophagus. Amylase and lysozyme are the two salivary enzymes that make up saliva. Amylase breaks down carbohydrates, and lysozyme is an enzyme that's active against bacteria. Your tongue will house your taste buds and also mucus. So that's what your tongue is good for. So inside the oral cavity, you see kind of at the top is the hard and soft palate. The uvula is this little kind of boxing ball kind of hanging down at the end. That's what will like raise and lift up when you do swallow to cover up your nasal cavity so that food doesn't go into your nose. It goes down the esophagus. You have the different teeth, incisors, canines, premolars, and molars, openings of submandibular ducts, which are coming from some of those salivary glands. The gingiva covers the mandibular alveolar process. The gingiva are your gums, and then you see the tongue there, which is a very important muscle to help form this bolus of food to help push it down your esophagus. A little bit about teeth. You have 32 teeth in the normal adult before you get any wisdom teeth removed. The incisors, canines, premolars, molars, and wisdom teeth You have 20 primary teeth if you're a baby before you start to lose them. They get replaced or come in later in adulthood. And each tooth, a little bit of anatomy about the teeth, has a crown, a cusp, a neck, and a root. The center of the tooth is called the pulp cavity, where different nerves and blood vessels go through. And then you have enamel covering your teeth. That's the white part of your teeth covering the crown. Enamel is the hardest substance in the body, even stronger than your bones. It's like bone, but it's incredibly tough and resilient to protect the teeth against abrasions. And if you think about it, what we put our teeth through is pretty strong. So we want a hard covering protecting our teeth. Cavities are the breakdown of that enamel, usually by acids and bacteria. So a lot of, acidic food, drinking a lot of coffee, wine, acidic citric juices is not good for your teeth because it breaks down that enamel. Of course, it's fine to drink coffee or wine or eat an orange, but maybe just wash out your mouth or brush your teeth afterwards to kind of keep your enamel intact. Because the breakdown of enamel can be caused from acidic food as well as bacteria. And that can just be from a lack of brushing your teeth or a lack of flossing. But a cavity is specifically a hole in the enamel that the dentist has to go in and then refill, usually with a type of concrete or plaster. Because enamel is so hard, the dentist has to fix your cavity with a very strong substance. So here's the teeth that you can see here. The incisors are the front teeth in the front and back. And then you have canines, which are kind of the pointy teeth that you have on the sides of the incisors. Then you have first and second premolars, as shown here. And then you have 3 molar teeth. And your third molar is the wisdom tooth. Many of us have gotten our wisdom teeth removed unless you have space in your mouth for it, which is totally fine. Often your third molar comes in during your 20s even, and it can be really painful when that third molar comes in. So that's why many people just get the molar removed ahead of time to avoid some of that pain. And then here are the baby teeth. You have 20 baby teeth, as you can see there. You can see where they erupt or come through the skin. And again, the third molar, the wisdom tooth, doesn't usually come until later. Here's the anatomy of the tooth and how it's held in place in the alveolar bone. So that's your maxilla. So the crown is the part of the tooth that you brush, and it's covered with this white enamel. Underneath that is the dentin layer. You'll see the pulp cavity with nerves and vessels. You'll see kind of a cementum layer, which anchors the tooth root to the periodontal ligaments that attach to the alveolar bone. So this is just a little anatomy of the tooth. Then the palate refers to the roof of your oral cavity. The hard palate makes up the anterior part, and the soft palate is in the back, the posterior part. And the soft palate, again, actually raises when you swallow to shut off the opening to your nasal cavity. So nothing goes into your nose when you swallow. Here we have salivary glands, 3 main types of salivary glands: submandibular below your mandible, sublingual below your tongue, and then the parotid, which lies on your masseter muscle in your cheek region. They all produce saliva that contains those important enzymes to break down food. Mumps is an inflammation of the parotid gland. So you might notice some swelling in your cheek region with mumps, but most of us have been vaccinated against that, so it shouldn't be a problem. So here we have the different salivary glands. The parotid gland lies on top of your masseter muscle, and you'll see these green ducts, which take the saliva that are produced from those glands and empty it into the oral cavity. The submandibular gland is below the mandible, and there's the submandibular duct entering the oral cavity, and the sublingual gland below the tongue, and lots of different green ducts and taking that saliva into the oral cavity from the sublingual gland. The pharynx is another word for your throat. It connects your mouth to the esophagus, and it has three parts to it. The nasopharynx is the part of the throat behind the nasal cavity. The oropharynx will be the throat behind the oral cavity, and the laryngopharynx is right behind the larynx or the voice box. And eventually I show pictures. We have a couple more slides of just words, and then we'll go through pictures. The esophagus is then the tube that connects the pharynx to your stomach, and it transports food to your stomach. It takes about 6 to 8 seconds for food to travel down your esophagus. So think about that the next time. Water probably gets down a lot faster, or fluids, but any sort of food takes about 6 seconds to get down into your stomach. The esophagus joins the stomach at an opening called the cardiac opening. And heartburn, what is this pleasurable experience, especially if you're pregnant like I am. I think I told you guys I'm due in June, hoping to make it through the end of our course. But heartburn occurs when gastric juices regurgitate into the esophagus. It can be due to a failure of this opening to close all the way, leading into the esophagus. Or it could just be caused by caffeine, smoking, or eating and drinking in excess. That can cause heartburn. Obesity can cause heartburn just because of extra weight and pressure on your stomach. It can kind of cause pressure to build up to force food or juices back into your esophagus. And that's where it cannot be pleasant in pregnancy either. So swallowing, how do things get into your stomach? We go through a voluntary phase, which you are controlling. So when you take a bite of food, your mouth or your tongue is forming it into a bolus, which is a nice slippery, slick kind of ball of food. And then your tongue pushes that into the oropharynx. So that's the voluntary phase, what you control. The pharyngeal phase is a natural swallowing reflex that is initiated when the bolus stimulates different receptors in your oropharynx. The esophageal phase moves the food from the pharynx to the stomach, and peristalsis is the specific kind of word we use to describe the wave-like contractions that move food through your digestive tract. And these are the phases of swallowing: the voluntary phase, creating this bolus of food, pushing it into the pharynx. During the pharyngeal phase, the soft palate is elevated so that no food goes up into the nasopharynx. We don't want that to happen. And then successive contractions will move this bolus of food through past the laryngopharynx. You'll notice here, this is a really important step, how the epiglottis closes over the larynx and the trachea so that no food goes into your trachea. That could lead to choking, because it could block the airway that air is trying to get in. And then you have different constrictors kind of relaxing and contracting as it's pushing the food down the esophagus. Peristalsis are wave-like contractions of using the smooth muscle in your digestive tract to kind of push the bolus along. Think of it like squeezing a Go-Gurt tube of yogurt along. That's kind of what these smooth muscles are doing in the esophagus, as well as other parts of your digestive tract. Then we get to the stomach. So we're just working our way down. It's located in the abdomen, so below the diaphragm and your lungs. This is your storage tank for food. It can hold up to 2 liters of food. It produces mucus, hydrochloric acid, and other protein digesting enzymes. Your stomach is incredibly acidic. Hydrochloric acid is the strongest acid. And because of that, it contains a very thick mucus layer that helps to lubricate and protect the cells of the stomach from that very acidic pH. And your stomach has a pH of about 3, which is again extremely acidic. Remember that 7 is neutral, and the scale only goes 1 to 7. So it's on the very acidic side of things. And the hydrochloric acid could easily kind of destroy some of your stomach cells. So the thick mucus layer tries to protect those cells against that hydrochloric acid. There's 3 muscular layers to the stomach: the outer longitudinal, the middle circular, and an inner oblique muscle layer. And that helps to kind of produce a churning action within the stomach to not only store your food, but also to start the breakdown of food even more. Rugae are large folds that allow your stomach to stretch. And chyme is what we call the paste-like substance that forms when that bolus of food begins to be broken down. So that bolus of food eventually turns into chyme, which is a paste-like substance that will form. The pyloric opening then is the opening from your small intestine, or from your stomach leading into your small intestine. And it's covered with a pyloric sphincter, which is a little ring of thick, smooth muscle that will open and close to allow the chyme to travel into the small intestine, which is our next stop in the digestive tract. Hunger pains is when you feel hungry, your stomach is stimulated to contract. So it's actually your stomach is contracting when you're hungry by very low blood glucose levels, usually within 12 to 24 hours after a meal. And if you've ever done like a fasting or a cleanse, you know that 12 to 24 hours after your last meal is usually the toughest because that's when these low blood glucose levels are causing your stomach to contract. So here's the anatomy and histology of the stomach, the lesser curvature, the greater curvature, these three muscle layers. Here we have the cardiac part of the stomach where it's opening, called the gastroesophageal opening. We have the fundus is the dome-shaped part of the stomach, the body. And then the pyloric region has a canal, an antrum, and here's the pyloric sphincter that'll open and close to allow food to pass into the duodenum, which is the first part of your small intestine. And again, these rugae are kind of the thick muscular folds to allow the stomach to stretch. I mentioned that your stomach is incredibly acidic, and that thick mucus layer allows for protection from that hydrochloric acid. If the hydrochloric acid gets through your stomach and creates a wall in the stomach wall, that's called an ulcer. That can be due to stress or various food that you could be eating. But ulcers are not pleasant because you literally have a hole in the wall of your stomach. Here we have an in-depth look at the histology of the stomach. So these rugae form what we call gastric pits, which are lined with all different types of cells. These cells will produce mucus, they'll produce hydrochloric acid. So food will get kind of stuck in those gastric pits, and these gastric pits also provide a passageway for everything that these different stomach cells are producing. Regulation of stomach secretions. We have parasympathetic stimulation. Remember, your parasympathetic nervous system is your rest and digest nervous system. We have gastrin and histamine, which increase stomach secretions. We divide it into a couple of phases. The cephalic phase is when the stomach secretions start to become initiated by the sight, the smell, the taste, or even just thinking about food can start these secretions from the stomach to get ready for a potential influx of food that it will need to help digest. The second phase is your gastric phase, where you have partially digested proteins and distension or stretching of the stomach. So when food actually enters the stomach, which will help to promote secretion. And then we have the intestinal phase, where we have the acidic chyme that has now formed. It will stimulate more neuronal reflexes and secretions of other hormones that will start to inhibit gastric secretions because it's on its way to enter into your intestines. So here we have cephalic control, so just smelling food, seeing food, thinking about food. Those chemoreceptors can start secretions of histamine and gastrin in your stomach just to get it ready for potential food influx. Gastric phase is then when actually food has been in your stomach and it causes distension or stretching of the stomach to release even more histamine and gastrin. And then the intestinal phase are when we kind of start to decrease the gastric secretions because things are ready to enter into the small intestine. Okay, so movement in your stomach. How does food get mixed? the muscles in your stomach cause kind of weak contractions, which will thoroughly mix the food to form this chyme. Peristaltic waves are stronger contractions that force the chyme through the pyloric sphincter to enter into your small intestine. And like we mentioned before, there's different hormonal and neural mechanisms that stimulate stomach secretions. And your stomach, it takes about 4 hours after a meal for your stomach to empty, but it might take 6 to 8 hours after a very high fatty meal. So this is just another way, another reason to just be careful what you eat, because any sort of bad or unhealthy food, very fatty meal, anything that you eat, you're putting undue stress on your body. And this just shows it. If you eat a normal, regular, healthy meal, your stomach can empty after 4 hours. If it's high in fat, it takes 6 to 8 hours. So just another kind of soapbox moment for me to encourage everyone, including myself, to eat healthy. What you put in your body, your body has to get rid of. So any undue stress, you don't want to put any undue stress on your body or your stomach by eating something high in fat. So here's movement of the body showing the mixing waves, the peristaltic waves, forming the chyme, and eventually how these peristaltic waves in purple are kind of pushing the chyme through this pyloric sphincter and into the duodenum. The duodenum, again, is the first part of the small intestine, and your stomach will do this movement to try to, mix the food into chyme, but then kind of force it through the pyloric sphincter into the duodenum. Okay, the small intestine then measures about 6 meters in length. So the small intestine is much longer than your large intestine, but it's called the small intestine for the diameter. So your large intestine has a much larger diameter. The small intestine has a much smaller diameter. But in general, your small intestine is very long. It's 6 meters in length, which is about, 18-20 feet. It's the major absorptive organ. And this is usually a good test question. Where does the majority of absorption or of your nutrients take place? In your small intestine. It takes about 3 to 5 hours for your food to pass through your small intestine, and it will contain even more enzymes to further break down food. It will contain secretions for protection against the acidity of the chyme, because remember, what's coming from your stomach is still very acidic. So your small intestine still needs a way to protect its walls from that acidity. The duodenum is the first part of your small intestine. It's the shortest part, only about 25 centimeters long. It contains different absorptive cells, goblet cells secreting mucus, granular cells, endocrine cells secreting different hormones. It contains microvilli on its cells and many folds to trap food particles in for potential absorption into the bloodstream. And your duodenum will contain ducts and openings for bile coming from your liver and gallbladder, and different enzymes coming from your pancreas. The jejunum is the second part. It's much longer, but not as long as the ileum. Again, it's a major region of absorbing nutrients from food into your bloodstream. The ileum is the third part, the longest part, and the ileum will eventually connect to the large intestine. So here we have the duodenum coming from your stomach, and it's kind of, that's as big as it is. It's kind of the shape of a C. So that's your duodenum, and then you have your jejunum, kind of the upper third, and then your ileum is the lower 2/3. And then we see what we call the ileocecal junction, which is the connection from your ileum to the start of your large intestine. And the cecum is this pouch, which is the start of the large intestine. And then we'll see how the large intestine comes up, called the ascending colon. This little guy here is your appendix. Hopefully none of you have ever had any problems with that before. It's usually filled up with a lot of bacteria, so if it ever gets infected even more, it could potentially burst, and that could be life-threatening if whatever's inside of it bursts and travels and infects a lot of the surrounding tissue. The mucosa of the small intestine, or the layers of the walls, The mucosa is simple columnar epithelium with 4 major cell types. We have absorptive cells, which have microvilli producing digestive enzymes that are absorbing digestive food. Goblet cells secrete the mucus that's protecting the layers or these cells from that acidity that's coming from your stomach. Granular cells also help to protect the intestinal epithelium from bacteria, and endocrine cells produce different regulatory hormones. The epithelial cells of your small intestine are located within kind of tubular glands called intestinal glands or crypts of Luberkuhn, probably named after the guy who discovered them. And these are at the base of all the villi. Granular and endocrine cells are located in the bottom of these glands, and then you'll have a submucosa containing mucus glands, also called duodenal glands, which are opening into the base of these intestinal glands as well. And eventually I'll show you a picture on the next slide. The epithelial cells in the walls of your small intestine have different enzymes bound to their free surfaces. We have peptidase enzymes, which break down proteins into amino acids so they can be absorbed. Disaccharidases break down disaccharides into monosaccharides or simple sugars like glucose for absorption. And here we have the walls of the small intestine. Here's what we call a villi, which are these finger-like projections. And then between the villi, we see these kind of crypts in between the villi. The villus itself will have lacteals, which is part of lymph, your lymphatic system, and then your capillaries. Movement of the small intestine. So how do things get moved through your small intestine? The chyme gets mixed and propelled along. Those are the primary mechanical events that occur in your small intestine. You have more peristaltic contractions, which proceed along the entire length of your intestine for variable distances and cause the chyme to move along. And then you have segmental contractions, which are propagated for only a short distance to try to mix your contents of the intestine together. At the end of the ileum, the last part of your small intestine, you have another sphincter called the ileocecal sphincter. It's at the juncture of your ileum to your large intestine. It maintains, it's kind of contracted most of the time, but when we have peristaltic contractions that reach that sphincter, it causes the sphincter then to relax and open. And that allows the chyme to move from your small intestine and into the cecum, which is the start of your large intestine. You do have a valve which prevents movement from the large intestine back into the ileum. As you know by now, things in your body should only go in one direction, whether it's blood moving through the heart or it's digestive tissue and digestive things in your digestive tract. So this valve just keeps things in the large intestine and prevents them from moving back into your ileum. So here we have, I've shown you a picture of what peristaltic contraction looks like. Peristalsis kind of moves things in one direction, whereas segmental contraction kind of mixes things. So it could move things forward and back. The material in brown, that's the food or the secretion or the waste. It can move it kind of forward or back to kind of diffuse it out to make it easier to pass. But segmental contractions can move things in both directions, whereas peristalsis just moves things along in one direction. But it's just the contraction of muscles throughout the GI tract. Okay, let's see here how far we're going to get today. Get a little bit further, and then on Wednesday we'll finish this up and start chapter 17. Maybe we'll just finish talking about the liver and then I'll let you guys go. But your liver is one of the accessory organs, so it's not actually involved in this tube of your digestive tract, but it plays a very important role in digestion. It weighs about 3 pounds and it's located in the right upper quadrant of the abdomen, right under your diaphragm. And it consists of a right, a left, a caudate, and a quadrate lobe. The porta of the liver is the gate where all the blood vessels, ducts, and nerves enter and exit. And your liver will receive arterial blood from the hepatic artery. And anything associated with liver will have this prefix, hepa, associated with it. So here's a look at your liver, looking at it from an anterior view. You can see different ligaments, different lobes. From an inferior view, you can see the gallbladder on the bottom side of the liver. You have what we call kind of the portal triad, or the porta, where all of your hepatic ducts and veins and arteries are entering. And then if we zoom in on some of liver histology, we see what we call these portal triads, which are kind of at the points of this little like hexagon shape arrangement of liver tissue. And these portal triads include the artery and vein, and then the duct. And the duct is what bile will go through from the liver. So the lobules are divisions of the liver with the portal triads at each corner. And a portal triad contains three things: a hepatic artery, a hepatic portal vein, and a hepatic duct. Hepatic cords go through each lobule, and they're separated by hepatic sinusoids. The hepatic sinusoids contain phagocytic cells to help remove anything foreign from your blood. And then the central vein at the center of each lobule, this is where mixed blood flows to the central vein to form your hepatic veins. Your liver is your body's main kind of detoxifying center. So anything that you absorb or that gets absorbed into the bloodstream goes to the liver to be detoxified and to be processed. So the blood supply to the liver is very intricate as it processes and kind of detoxifies anything you put into your body. The hepatic duct transports bile out of the liver, and the common hepatic duct is formed from just the right and left hepatic duct. So you have a hepatic duct going to the right and left lobes of the liver, and then the common hepatic duct is what happens when they both come together to form one. This cystic duct comes from your gallbladder, and your cystic duct and the common hepatic duct will join to form what we call the common bile duct. And the common bile duct is formed when the two come together. So this just looks at how bile secretions come from the liver and how pancreas secretions come from the pancreas. So bile is an important secretion that's made in your liver, and it's stored in the gallbladder. So people can live without their gallbladders because the gallbladder just stores extra bile. Here we have hepatic ducts going into the liver lobes. The hepatic ducts form the common hepatic duct coming out. The cystic duct is coming from your gallbladder, and then the cystic duct and your common hepatic duct form what we call the common bile duct. And the common bile duct enters into the small intestine at this duodenal papilla, which is an opening. What also enters the small intestine at that duodenal papilla is this main pancreatic duct, which carries digestive enzymes from your pancreas. So this is a way that different digestive enzymes or bile get into the duodenum through these duodenal papilla. We also have a little papilla up here where the accessory pancreatic duct enters in. So a little bit more the functions of the liver. It has digestive and excretory functions. Your liver stores and processes different nutrients that your body needs. It detoxifies harmful chemicals, drugs, toxins, alcohol. This is why alcoholics have really bad livers, because again, you're putting a lot of stress on your liver when you drink alcohol. Your liver synthesizes new molecules, and it secretes about 700 milliliters of bile each day. And bile is important for diluting and neutralizing stomach acid, as well as breaking down fats. So we need bile to break down the fat you eat, as well as trying to neutralize some of the stomach acid. The control of bile secretion and release is under nervous system stimulation by the vagus nerve. The vagus nerve will secrete or control the secretion of secretin and cholecystokinin, as well as bile salts, everything needed to kind of control bile secretion from your liver and then store it in the gallbladder. So I'll stop there and we'll start on Wednesday, finishing up the pancreas and the rest of our digestive system talk. And we'll also start chapter 17. So I'll go ahead and stop the recording